You are conducting a study to see if the probability of a true negative on a test for a certain cancer is significantly different from 0.71. You use a significant level of alpha equals 0.002. Now, in this case, we've already been given what we're going to use for the null and alternative hypotheses. But ultimately, that statement comes from the claim. And the claim that we're testing here is that the probability of a true negative on a test for a certain cancer is significantly different from 0.71. So the probability is significantly different from 0.71. So that means the claim is the statement that the probability of this is not equal to 0.71. That's what it would be meant by different from, so it's not equal to. The level of significance that we'll be using here, which is our alpha level, is 0.002. And that certainly does set up our null and alternative hypotheses correctly, but it is good to make sure we understand which statement in the hypothesis is the claim. So when we go to interpret it later, it will make more sense. Now we have a sample of size n equals 515 in which there are 345 successes. So what is the test statistic for this sample? Now there is a way of using formulas, but I'm going to be using technology to come up with the values here. So what I am using is the TI calculator. If you're using something different, that's fine. Just make sure you understand how it works to get your answers that you need. For those of you using the TI calculator, what you can do is press the Stat key and come over to the Tests menu. And what we're doing is we're doing a test for a proportion. So notice how these are labeled. We have one prop z test. So this is a hypothesis test for a proportion. The z stands for the normal distribution, and that's fine here, as long as n times p and n times q are both greater than 5. And let's try this out here. So p sub 0 is the value in the null hypothesis, so 0.71. X is the number of successes that you observe out of your sample. So we had 345 successes out of a sample of 515. This next statement, this is the symbol that we see in the alternative hypothesis, and it's a not equal, so that's telling us we're doing a two-tailed test, so we'll leave that checked. Press calculate, and at this point, we're given the values that we are needing here. So z will round to 2 decimal places, but just follow the instructions given in the problem. So negative 2.01. So I'll say that's a z-score. The p-value is a probability here, so I'll take that to 4 decimals, 0.0449. Now the p-value is less than or equal to alpha or greater than alpha. So let's see here. So I have my p-value and I have alpha. I'm going to change these into decimals because that eliminates some leading zeros and it makes it a little easier to compare. So 4.49% compared to 0.2%. Well, certainly 4.49 is larger. And the rule is, if p is low, the null must go. And in this case, the p-value is large, so we fail to reject the null hypothesis. So I'm going to write that here, but that actually gives me the answer to the next couple of questions here. So we decided the p-value was greater than alpha, so we'll check that. The test statistic leads to a decision to fail to reject the null hypothesis. And as such, the final conclusion, let's see. So if you read through all of these, what you'll find is there's not much different between each statement. In fact, the last part is just a restatement of the original claim in each one of these. What is different is, first we have there is sufficient evidence or there is not sufficient evidence. This one doesn't have that, but it is kind of implied. And then this one is an is not. Then later on we have evidence to warrant rejection of the claim. And this one says warrant rejection. This says support the claim, and then this one says support the claim. So we need to decide if there is or is not enough evidence to reject or support the claim. And what that comes down to, in the statement of the decision, if you fail to reject the null hypothesis, it's not a very strong statement. If you rejected the null hypothesis, that is very strong. So you would go with the stronger of the two statements between is or is not. So if you reject the null hypothesis, what you do there is you put is sufficient evidence, and if you fail to reject, you put there is not sufficient evidence. And as it turns out, this is not even an option. It's just thrown in there to throw you off. You can only choose to reject the null hypothesis or fail to reject the null hypothesis. Okay, so what that means is we can eliminate a couple of choices because we have to have the wording is not. So anything with is sufficient evidence can be thrown out. So A is not an option for us, and C is not an option for us. And that just leaves D or B. And what that comes down to is, are we going to try and reject the claim or support the claim? And to decide that, there really is a very easy way of determining that. And effectively, if your claim is in the alternative, you're trying to support it. But if the claim is in the null, which in this case it's not, then you're trying to reject it. So in this case, we are trying to support it, so we would state answer D is the correct one. So there is not sufficient evidence to support the claim that the probability of a true negative on a test for a certain cancer is different from 0.71. But if you wanted a little bit more idea as to why that works, just understand that what we did is we failed to reject the null hypothesis. So if we fail to reject it, we're not saying that it's true, but we're certainly not saying that it's false. So let's say it's true-ish. So the null hypothesis is, we'll just, for argument's sake, say that that's a true statement because we failed to reject it, which leaves this statement to be a false statement. So if this is a false statement, then what we need to do is, and that is the claim, we're saying the claim is false. So what we need to word here is in such a way that the claim is not is false. So there is not sufficient evidence to support the claim. So we're stating that it's false, but not directly stating. And that's why we have this not quite as direct result from the decision. And that's where that comes from.